read the question, get the diagram first. Get the related diagram. How much of time it takes? You can do by two methods. Like just now I discussed now the integration method. You can totally avoid integration and you can bring the ellipse idea and you can work out the problem. So basically, so we'll begin like this. This is sun. It was initially it was revolving in a circular orbit. This is sun. It was moving and suddenly it stopped here. Suddenly stopped here. Now, what is the time it will take to fall into the sun? Time period of revolution of planet's revolution. You have to assume that one. Circular. See, I think planets will revolve in what? Will revolve in elliptical orbit only. But here he has put a condition. Earlier it was revolving in circular. Now suddenly it is stopped here. Now what is the expression for in terms of time period when it revolves in a circular orbit? Any formula for this? Let it be t. Let's not bother. So, and what is the radius of that? Let it be r. Let me construct first thing. No. Can we assume some sort of ellipse here? And so what can be this? This will be semi-major axis. And what is the distance planet? No, PS should be equal to R. And what should be the A? A should be R by 2. And what is the time taken for it to be in elliptical orbit? Any formula you have? And if eccentricity is almost equal to 1, so this will become like almost like a straight line. No? Little bit of take help of the ellipse idea. So the time period is proportional to, so earlier the time period t square is proportional to r square. Now in elliptical orbit, the time period should be proportional to t, right? This should be proportional to square of semi-major axis.
T square
Sorry,
proportional to R cube.
cube. This is for elliptical. This is for circular. What I know. Will I agree this? And from the diagram, what is A? A should be equal to R by 2. So let me do one thing. TE square by A cube should be equal to T square by R cube. TE square equal T square A by R whole cube. What is A? A is R by 2. So this will, everything will become T square by 8. TE square should be equal to T square by 8. Then what is T? Time taken if it were completely elliptical orbit. So time taken to move from P to S should be TE by 2. And what is TE? TE from here should be root 8. Okay, substitute now. This will be T by 2 root 8. Agree this one? I think you can further adjust root 2 by 8. So this is what happened. We assumed it. It almost moves in. It will move in what? Straight line only. But if you make eccentricity equal to 1, eccentricity is approximately equal to 1. In that case, so we can assume it to be like a straight line. Then I can bring that idea of that one. Or simple mass based application. So you can also do by what? The energy of satellite E equal to just now previous problem what we did, mass of sun, mass of planet by 2r. Then differentiate this dE r. So the radius of r, this r will vary from smaller to 0. Then what is the time taken? This will be very lengthy, this approach.